Okay, we've got two particles approaching opposite directions, so we'll have this one going this way, this going this way, this one going with 2u, and this one going with u. Afterwards, we can't be sure which way they're going, but I'm going to go that one that way, and this one this way. Call that y, this one x, could call it p and q, whichever helps you remember it really. Okay, so conservation of linear momentum, 6mu, we take to the right as positive, take away 2mu equals 2my, take away 3mx. Let's take x this way. So I'll keep this as a plus 3mx. Okay, so I'm taking x to the right, y to the right, which means I can make this a plus. If x is in the wrong direction, it will come out to be negative. So I'll keep them both going the same way, unless I'm told otherwise. The m's will cancel, so I'll get 4u is 2y plus 3x. Okay, that's one equation. I'll keep hold of that. The impact law. So speed of separation, which is y take away x, equals speed of approach times e. So I get 1, 2, 3 ue equals y minus x. Okay, equation number 2. So now I tend to personally prefer to write them out again, but not everyone does. So I've got 3ue equals y minus x, and 4u equals 2y plus 3x. So if I multiply the bottom one by 3, I get 9ue equals 3y take away 3x. I know that 2y plus 3x is 4u. I'm going to add them together, and I get 4u plus 9ue equals 5y, and I get y equals, take a factor of u out, u times 4 plus 9e over 5. Alright, now it tells us the speed of p after the collision is half u. The speed of p is going to be x, so I've got y, I need to find x. Okay, so I can use one of the equations, doesn't matter which one I use. I'm going to go for 3ue equals y minus x. So 3ue equals y, which is minus x, and then I'm going to move the x that way and this way, so x equals 4u plus 9eu over 5. Take away this, I'm going to write this as 15ue over 5. So x equals 4u take away 6ue over 5 equals take a 2 out, I suppose, 2 lots, which equals, take a factor 2u out, 2 take away 3e over 5 is equal to x. Okay, so we know we've got x now, we've got speed of p, and we know that equals a half u. So we've got half u equals 2u, 2 minus 3e over 5. Cancel the u's, times by 5 and divide, so 5 over 4, 2 minus 3e, add the 3e, take away that, so we get 3e equals 3/4, so we get e equals 1/4 as required. Okay, so now the next bit, the collision between at the point A. Okay, right, so we now have 2m moving with a velocity y, which is this, towards a wall. Okay, so this is A, if you like. Okay, and then meanwhile p is also moving towards a wall, but clearly at a slower speed, and we're trying to find how far p travels in the time it takes q to travel the whole distance d. Alright, so we know that time is distance over speed. So the time it takes, which is the distance over this value of y, and we're told we know e is a quarter now, so this actually equals 6.25 u over 5. Okay, so we've got that, so we know that d over 6.25 u over 5, which means I can move the d up to the top. Okay, so that's the time it takes for q to hit the wall. Now for p, this is for q, so for p, the distance it travels is speed times time. In this case, the speed is a half u, and the time we know is 5d over 6.25 u. Okay, and we get the u's cancelling. 5d over 12.5, which equals 2/5 d. Okay, so therefore don't forget the concluding statement. So p travels 2/5 of d, which implies p is 3/5 d from the wall. Okay, don't forget the concluding statements. Right, now, final one. We've got q rebounding from the wall and then collides. Okay, right, so let's do another diagram. I always think it's a good idea to have a little diagram to help you out. So we've got, here's the wall, we've got P over here, travelling with velocity half u, and we know the distance away is 3/5 d, and Q is rebounding off the wall with velocity which is 1/5. That's a coefficient of restitution, 1/5 times 6.25 u over 5. Okay, so 6.25 over 25, so that is 1/4 u. Okay, so the ratio is probably simplest here. The ratio of the speeds is 2 to 1. Therefore, the ratio of the distance travelled is 2 to 1. And we know it's 3/5, so therefore meets 1/5 d from the wall. Okay, because this one would have travelled 2/5 in the time this travels 1/5, so therefore it's going to meet sort of here. Okay.